Hello, welcome back to Alien Space Talk. My name is Andy from Space for All Education, and today's broadcast is on Venus, a second planet from the Sun. So we're going to take a deep delve look into it, the world of extreme temperatures, pressure, and extreme conditions. So let's dive into the enigmatic beauty of Venus. Venus is the second planet from the Sun. It's about 108 million kilometers or 67 million miles. It's approximately 2/3 of an AU. Despite being small in size and structure to Earth, it's actually about the same size as Earth. It's just a tiny bit smaller. And unlike other planets in the solar system, it has a thick atmosphere composed of carbon dioxide to create a runaway greenhouse effect. That makes Venus the hottest planet of our solar system, even hotter than Mercury, which is the closest planet to the Sun. The surface temperatures on Venus reach an astonishing 465 degrees Celsius or 900 degrees Fahrenheit. It's enough to melt lead, one of the toughest materials on Earth. And when it says it's a runaway greenhouse effect, on Earth we're suffering the greenhouse effects now. Our polar ice caps are melting, and if it keeps melting, we're going to get flooded. But what happens if we keep going and we keep making it worse? Well, the heat will keep building and building and building. We get hotter and hotter and hotter, which means that water will let ice turns to water, which then will turn into water vapor and create a thick atmosphere. And we're going to have an endless cycle of things getting flooded, getting dried up, and deserts will get worse and things will just get bad. And we don't want that. That's a bad place to be in. So Venus is what will be if we don't start looking after planet Earth. Really, really important. Okay, so we need to make sure we're looking after Earth. So by studying Venus helps us make sure we don't make those mistakes. So the atmosphere on Venus is so incredibly dense and heavy that the surface pressure, this is the pressure, remember, is 92 times that as on Earth. This would be like being 900 meters or nearly 3,000 feet underwater on Earth. So if all our polar ice caps melt, all the ice melted, we get all that water. And it makes us all sink, and we go right to the bottom of the ocean and even deeper, about 3,000 feet. We have all that pressure on us. Oh, that's not nice. We don't want that. So it's not just the pressure that's intense, which is highly dangerous. The atmosphere is filled with clouds of sulfuric acid, which makes it an incredible hostile environment for life as we know it. Now, sulfuric acid will burn your skin. It's highly dangerous, highly controlled because it's dangerous to us. You might see it in schools for some experiments with your teachers or something like that, but generally you don't see it out and about. It's dangerous stuff. And the atmosphere, clouds of that, and it rains on you, you will melt. We don't want that to happen, so let's make sure we don't poison our atmosphere anymore. Okay, so Venus is highly dangerous. One spacecraft has landed on Venus, and it only lasted 8 minutes, but it was able to send back this information to us, which is why we know what we know now. However, one of the most fascinating features of Venus is its slow and retrograde rotation. While most planets in the solar system rotate the same direction as us, as they orbit the Sun, Venus spins backwards. How odd! The problem known as retrograde rotation, and it does it very slowly. One day on Venus, that's the time it takes the planet to complete one full rotation on its axis. So one day on Earth is 24 hours. One day on Venus is different. So it's equivalent to 243 Earth days. In fact, a day on Venus is longer than a Venus year, which is 225 days. So you think about it, one day is 24 hours, one day on Earth. On Venus, it's 243 Earth days. I'll let you work out how many hours that is. Put it in the comments if you can. While a year is 225 days, an Earth year is 365 because we're slightly further away. That's why we've got a slight difference of year, but its day is longer than its year. Very strange planet, and it's spinning backwards. Venus' surface hides behind thick clouds, is a rocky landscape dominating vast plains, highland regions, and we mean thousands and thousands and thousands of volcanoes. Some of these volcanoes are massive, like Matmons, which is about 8 kilometers or 5 miles high. Although there is still a debate among scientists, some evidence suggests that Venus may still have active volcanism or volcanoes, which would make it one of the few places in the solar system that has active geological processes. Okay, what that means is that the volcanoes are still active today, just like on Earth we have volcanoes going today. Venus still has active volcanoes, but if it has active volcanoes, that means it also has active earthquakes. So it's going to have one and the other. They work in conjunction with each other. So the geological process on Venus is still very active, more active than it is on Earth. So we only have the odd volcano going here and there, or the odd earthquake. We don't have half as much as what Venus does. So we need to watch that. And by studying it, we can help understand our planet and how tectonic plates move and how volcanoes work better, how they keep their fuel going and everything like that. So it's important that we keep studying Venus. The surface of Venus also features what is called tessera, which is a region of highly deformed terrain. These areas are believed to be some of the oldest on the planet, offering a window into Venus's geological history. Unlike Earth, Venus does have plate tectonics as we know them, but its surface is still shaped by intense volcanic and tectonic forces. So even though there's old structures, old things on there, these tectonic plates must be moving incredibly slowly. Earthquakes are still happening, but it's not affecting terrain too much. Lava is still flowing, volcanoes are still spewing things out, earthquakes are still happening, shaking stuff, but it's not affecting it that much. But it's still highly dangerous. In terms of exploring Venus, Venus was the first place by spacecraft, which was the Soviet Union's Venera program, achieving the first successful landing on the planet in 1970. That's over 50 years ago. It landed and provided close-up images of Venus's surface, revealing a rocky, barren landscape. Most recent mission, like NASA's Magellan orbiter, have used radar to map the surface of Venus, uncovering its geological features in detail. So we're able to see through those clouds. So in 50 years, we haven't been back there. Obviously, Russia did it first. They did a brilliant job, but the lander landed on its side, sent back some data, but not much. But it gave us a good insight to what's on Venus. Then NASA did their stuff, the Americans, NASA, did their stuff. They sent a probe there, and they scanned it from the sky. And we got a lot about a lot of what the landscape's like, but not what's underneath the clouds. Not what the atmosphere is like and things like that. Not like what Russia did. We just scanned it from the sky. A bit like looking at the ocean. Looking at the ocean floor. We can see the ocean floor, but we couldn't tell you much about it. We're still studying it and we're still trying to find out. So why is Venus so important to study today? Helps us learn about the potential fate of Earth-like planets, such as what could happen to us if we don't look after Earth. The effects of extreme greenhouse condition. We have to stop polluting. We have to recycle better. We have to do better. By studying Venus, we gain insight into how climate change can transform a planet's environment, which has implications of understanding of exoplanets and other star systems as well. So by studying this, we can see, hang on, if we don't look after Earth, this could happen to us. But also, is this also happening on other hot planets? Maybe the hotter planets aren't always the closest one to the star, and we don't know. So we're looking at that to learn, so we understand better. So we look at how planets are in the Goldilocks zone, like Earth is, and even though Venus is in the Goldilocks zone, but it's closer to the sun, it's still highly dangerous. Could we live there? Not yet. We've got a long way to learn on how to deal with that environment and be safe. There's lots of us to still learn. Unfortunately, that's it for today. I know it's short, it's sweet, but we have limited knowledge. Other things to remember about Venus, short note, is that it has no moons, its closest one, it spins backwards, and it's highly, highly hot and dangerous, and it rains acid. It's highly dangerous to us, so we can't go there yet. Maybe one day you can help us explore it, learn better, and learn how to use other materials to keep, when we do send a probe to Venus, other probes to Venus, we can make sure they're safe and we can get a better look at Venus. Just like at the minute we're sending probes to Mars, maybe you can help us do that and do it better. All I'll say is keep looking to the stars, keep learning, and I hope you're enjoying. Take care.